So my name is Ram, and I'm working with Formula Bharat from last three years now. Like since we started electric category, and I'm basically looking after electrical uh, event in terms of scrutineering and accumulator inspection, main vehicle inspection, document reviews, and our rules mainly. So this is like overall I'm looking after, and so this is my background, and in reality I work on electric vehicles, so this is kind of related to my passion as well, so which I follow as a whole. So I will start with questions. There are a lot of questions being asked by many of you guys, and I think I will say like there is Shravan Sriram who has asked like what design flow would be most suitable for a team that is taking its first step in building an electric vehicle. Similarly, like there are same questions like Tushar has also asked that design ideology and steps to be followed for FSCV for a first year team. And similar on the similar lines, like there are a lot of questions being asked like how to start in electric category. Like if you are starting you are already in a CV category and you want to start in EV category, then how should we start it? This is like asked by Jashanpreet Saini, like how can a CV team shift uh, easily to EVs? So I want to put more focus of this session in the start on the topic like transitioning to an EV car, and then how should you proceed with the design. So I have prepared a few slides for it, so I will just go through those slides in terms like to reply these mainly these 3-4 answers. So look, can you all see my screen first? Hello? Kathy, can you confirm you can see my screen?
Hi, yes, it's clear right now.
Okay. So we'll start with the first question that is like more commonly asked that I already said, like how to start with design of a new race car. I think I have just divided this procedure of like vehicle design for a Formula S1 car in like 5 steps. Like first you start with like benchmarking, then you go to concept design, then the engineering part of it. Then you start building up the real vehicle, and then you do testing and validation. So this is like 5 main phases, and even the conventional vehicle goes through all these 5 phases in reality. Now, in the first step, when we say like benchmarking and target specification, this is a more generic terms where you start doing your studies. Like you want to build a vehicle, but what exactly you want to build? Is it already built? Then you start benchmarking it. You start benchmarking your competitors, like few cars which are already built. You start to search online, and you start to search like what regulations the design should be compliant to, and then you see what kind of components or systems the vehicle will have. These are like few of the steps which are suitable for new teams which are starting in EV space. Like attend the events happening globally. First of all, like you should start attending the event even as a guest if you are not participating as a team. Go there, talk to the teams who have already done it, and try to see what kind of components they're using, and try to understand their challenges. So if you come to an event and then ask the teams, this is like the first point to start, I will say. Search online. There are like lots of colleges who have their design open. Like if you just go to their Facebook page, or like if you just search FSC or FSG or Formula Bharat teams, a lot of them have their design open online, so you can have a reference. Don't copy paste. Like you can just do a benchmarking, like what kind of systems those team has used. One thing which I will suggest you to do is like FSG releases a magazine. This is not a handbook which I will say. So generally, like if you go to FSG website, you will see they generally have a magazine which is released, which is really important for you guys to see. I will just share my second screen if I can. Just a minute. Yeah, it looks like this. Like these are some magazines from FSG. A few of your students have also asked the questions like what kind of motors are used in electric vehicles, what kind of components are used. These magazines of Formula Student Germany are will give you that information to the point. So this is like a sample, like I have just opened a magazine of Formula Student Germany 2019, and these are some cars, and it line out most of the specification of the cars. Like you can see here what kind of motor type they have used. They have used Iramax 228, number of motors, max power, batteries. So most of the systems in terms of powertrain, you can go from here. So this is your benchmarking. Like this is a best source of benchmarking if you are entering into Formula student competitions. So it is not only just one car. Like there are all the cars participating, and you can get the data of this for a lot of years. I'll say like 16, 15. So the one has I open is I guess the 19 one, 19, 18, 17. So you can see every year EV teams, what kind of components they use. So this is like one of the questions which was asked again, like what kind of components generally teams uses. So you can go and see these magazines. I think hopefully other competition may also have similar magazines, but I'm not aware of as such. But this is a one which I feel like may really help you guys to get up speed, like in terms of benchmarking. You can see what kind of systems already designed by teams. Okay. So this is important point. And then like you can, this is really important. Like there are forums which are available, which you can refer, like Formula Bharat have a forum, FSAE, generally Reddit also helps. So these are like some generic forums where these things are already discussed. So now you have already started doing a research, and I think this first step will give you a lot of clarity on what exactly you are going to design and how your vehicle should look like. Then I will say the second most important thing is rule book. Rule book is the, I will say, like everything whatever you are going to design has to be as per the rule book. So the benchmarking and study has to come with a study of rule book as well. So you need to understand what kind of rules you should be compliant to. Then finally you mix both of these things, benchmarking, regulations, and then you start to get some targets for your vehicle. Till now, where there is no physical thing, we are just conceptualizing everything right now. For vehicle, when I say in terms of targets, there can be more parameters you can think of in terms of targets, but mainly when I think of targets, like I will say in terms of performance, like what kind of speeds you want to achieve, what kind of accelerations you want to achieve, you need to write that down. What kind of weight you are targeting. So you can see from the benchmark what kind of weight in general the vehicles have based on their battery capacity or what kind of systems they use. Their range generally in our case, range I will talk about a bit later as well. Like range is something which is really straightforward in Formula student cars. Another one is cost, which is also important. These targets, which are at vehicle level, you will decide, they will ultimately will transform into your component level targets, which will be like battery, what should be the weight of the battery, size of the battery, chemistry of the battery. So you need to start looking for that as well. Similarly for motor, how many motors, uh, weight of the motor, charger, and then safety functions. We will go through them in a bit more detail. So I will just move to the next slide. But the main thing is you need to start conceptualizing your targets. See what is the performance that other cars are able to achieve. Like we have an acceleration event. What is the time you are looking at? Like 0 to 60 in how many seconds? This is like a one target. So you can see the acceleration scores of other events, and then you can see, okay, if we even target 7 seconds or whatever you are going to target, you need to power your motor accordingly. So this is one thing which you need to say. Or if you want to target efficiency event or like endurance, then it can be a different thing. So you can see what scores are there already teams are achieving, and then you can have a reference and achievable target for you. So next step is once you have done all this study, you have a lot of data from your benchmarks, from your competitors, and then you have studied the rule book. You will start to conceptualize your powertrain architecture. architecture is just a high level architecture where you will see where you are going to place your battery pack, what is the voltage of the battery pack, and what how many motors are you going to use, what kind of transmission are you going to use. Like tires are obviously four, then DC-DC converter is it will it be there or not. So there can be more systems in this architecture. So this is like a sample architecture which I have prepared, but you can have a different architecture so that you can start thinking about what kind of system actually you are looking at on paper. This is really important part, which is I think most of the team must be doing, which are already there developing their components, is component sizing simulations. Generally, like these simulations will give you the specification of your component. So like we already know that we have some performance targets like weight, range, cost, and uh, range, cost, performance, and weight. So from these four, we need to just derive a few things like how much battery power you need, how much motor power you need, what is the energy kilowatt hour capacity of the battery that you need. So these things has to be done, and these has to be come from these simulations. For these simulations, I try to uh, give an overview of like how it is generally done, like when we comes to simulation. Generally, like in normal electric cars, conventional electric vehicles, they use like an NEDC cycle, like a drive cycle for this simulation where it is supposed to run. For you, it is like a curry speedway track, which is like where your vehicle is supposed to run. I think based on your track, you can try to get like simple kinematics equations can give you like what kind of speeds you can achieve from this length. You can get these dimensions from Google images. uh, like Google Maps can give you these dimensions, but generally it comes from the track, like what kind of speed profile you are going to expect during endurance. This will give you like different kind of zones, like acceleration zones, braking zones, and all different kind of zones. This is kind of a drive cycle, which I will say. And in this drive cycle, we have like endurance track for like 22 kilometers, I guess. This 22 kilometers, you can add some safety factor to it, like you can design it for 25 kilometers or like 30 kilometers. And remember here, taking into consideration the derating of the components, because battery may not be able to supply an equal power at low SOCs as compared to high SOCs. So there are like multiple factors you need to consider, but this is like an generic thing which I'm telling. Like you can have some kind of speed profile. You can use this profile as an input to your simulations. So you have like driving cycle for identification for range, target performance speed line. This is simply like a speed line. Like if you are targeting 0 to 60 in 5 seconds, 4 seconds, you need to give this as an input. And this is like a top speed, which I don't think is much of the relevance in our case. So simulation is there that you need to simulate vehicle dynamics, transmission, motor, battery, and then finally it will give you a lot of requirements. So this will give you basically your component requirements. Component, when I say, this is mainly motor and battery. So I will switch back to my original slide. Yeah. Once you have done these simulations, I'm not telling like you need to use any simulation software. These can be done in Excel as well. These can be done in any other software. You can use MATLAB as well, or like any other simulation software which is available. So this is important step, but like you need to know what is the power that you are looking for. Next step, which is like your purchasing team, you should have some specific persons who will look out for the vendors and suppliers. So you need to search, okay, like this is the specification you need, this is what you need, and it should be changeable. Like right now we haven't bought anything, so you can go back and change anything, because this is most important step. Being in India, I don't think you will get all the components of your choice with the lead time that they will give. So generally you need to make a list of suppliers which are available. if you go online and search, like you can, and I already shown you the magazine of Formula in Germany, where you can get most of the components which Teams uses. Here, like you can list down for different systems what kind of component suppliers are available, and then on depending on various factors, you can start, yeah, like choosing one and like not choosing others. Like you can start taking one by one. Like, is it feasible? I will say one thing which I see teams struggle a lot is with respect to lead time of these components. Generally, these are shipped from outside, like maybe China sometimes, or like Germany. They have a big lead time. So if you are designing this, like if you want to have some components from outside India, then be cautious that you may need to suffer with a lot of lead time, and like yeah, which may hamper your complete design. Because I have seen a lot of teams which finally doesn't end up coming to the event just because their components were delayed. This is just a component selection till now. The next logical step after this will be uh, kind of, you will start putting, so now you know your components. You will see that these components come with their own specifications, their data sheets and everything. So now you need to start putting some CAD modeling to it. I'm focusing more on electric side of it. I think like mechanical CAD and everything will be in parallel. So that process is more or less similar here as well. Like the weight distributions will be different for the chassis, but like the components you will finalize till now will give you that. You need to start putting each of your component into models. Like you can start putting battery pack model, your motor model, your cells, everything. So you start putting everything in a component model and start to see how you can package things, what wiring you need, wiring length, how to do the integration part. This is still, everything is virtual. In parallel, you have may have already ordered things, and your things will be like you have ordered all the components, they may be still not arrived to you. But and these can still change, because if let's say this whatever spec you have finalized not available, then you can always switch, and then this is still soft, like only CAD model, so you can change it later and you can start finalizing your concept at least. In parallel, this is like we are designing an electric vehicle, so most of the functions which are required for safety has to be developed on PCBs. So you need to see like shutdown diagram, and you need to start developing the PCB, your control logics. So you may need to start looking at in parallel like embedded software development and hardware development. These can be done in parallel, and these are independent of like most of the components, because these are functions that are going to come from your rule book. Now, once you have the components arrived, you can start testing the components in terms of how those components perform. In reality, you can start integrating them subsystem wise. You can start assembling the pack and then start testing. So like everything is still at component level. You start doing integration. Then you build up a prototype. I think now most of the steps are same as a conventional vehicle. Like you start building a prototype, you do all the vehicle instrumentation, like whatever is required. Then you start doing the validation of whatever targets you have finalized, like are we able to achieve those targets or not. And then yeah, validation and mainly testing. Apart from it, like one more thing which I wanted to tell you, like this is a slide I just put to give you an impact of mainly battery on, on different things. These are like few of the datas which are easily available on internet. I just compiled them in a slide. This actually gives you a understanding of the main thing, which is weight. Because till now I have talked about like performance in terms of range, in terms of 0 to 60 or anything like that. But weight is mainly decided by battery in electric vehicles. So if you see here, what I'm trying to show here is like your weight is linearly increasing as you increasing the battery pack size. So be cautious, like range is also an important factor. So you, in our case, range will be fixed. I will say like range will be around like 22 to 30 kilometers, but that will kind of limit or weight as well. So so weight is something which you will require for rest of your calculations, like when you will be doing different simulations. So you can have a reference weight once your battery is finalized. So more or less like other components doesn't affect that much. To it. This is like I tried to put a sample sheet for like what kind of battery parameters you will end up with. This is with respect to like a battery pack, but I was not able to complete it in that terms. But in general, like you can start with like you will have some parameters like capacity that you need to finalize, nominal voltage, what voltage you are going to use, continuous current discharge, peak discharge, weight of the battery, volume of the battery, operating temperature, and life cycle requirements. This is like a generic thing which I think I tried to answer the question of how to start, and I think this covers most of it in terms of how you can start looking at the EV vehicle design. Okay, so I will move to the next question, which is which was asked, and the next question is about a lot of. Okay, so next question is asked by Monik Ghosh, and he asked like, does the voltage drop on peak current draw from a battery affect performance? Clearly, there is a drop in power output as P is equal to V minus IR into whole I. And is my concept wrong? And how to properly estimate the number of charging cycles that we will need for a season? So, in terms of first, I will ask like this question part by part. First question is, does the voltage drop in the peak current draw from a battery affect performance? I will say yes. We are talking here about electrical components. Everything which we have here is in terms of uh, currents, and if you have more current you will have more losses, and you will have in terms like uh, more losses means like loss of efficiency. I have seen teams coming at Formula Bharat with uh, low voltage battery packs in terms like 72 volts battery pack or even 60 volts or 100 volts battery pack. And these teams generally end up having like fuses of very high ampere ratings if they want to increase their power. And these systems are not efficient because for low voltage systems you need to see like you need to supply very high current, which in general like results into a lot of losses. So on a long term, I know that for a short term goal you cannot have a battery pack designed for 600 volts or something like that, but I think the best idea for to make an efficient car is to have a voltage as high as possible so that you can reduce the losses. Now to answer this question only with respect to internal resistance of the battery, we remember that lithium ion batteries operate in a particular voltage zone, which is decided by like there is a lower cutoff voltage, and which will get triggered whenever you have some voltage going lower than some particular voltage. Let's say if your cell have a voltage range of 2.5 to 4.2 volts, then like 2.6 volts below, if cell voltage goes, then you can have your BMS will stop. Yeah, like your shutdown circuit will open. So in that terms as well, your circuits will trip easily if you have high internal resistance in your battery. So in summary, like answer is yes. Like the current actually affects voltage drop or actually affects the performance, because that voltage drop actually accounts to the loss, and that we don't want. That's why we try to design our systems for really high voltage and batteries to have like less internal resistance. How to properly estimate the number of charging cycles? This is the third part of his question. How to properly estimate the number of charge cycles we would need for a season? I think for a season, you won't need much charging cycles. Like you can, because at the event, like you actually don't need much charging. In terms of much, I will say like even if you take a number as like 50 or 100 will be sufficient, because in terms of charging cycles, even for most of the components, I will say that we don't actually see that the lifetime is that much important in a Formula Student car with a short lifetime. So think there we can go with like a very large charge, small number of charge cycles. I think this is an important specification for the batteries, and you can see like most of the cells will comply. Like you can use most of the cells if you see in terms of charge cycles. Uh, so this is not a big factor for us, but yeah, you can see like this will be mostly will be compliant to when whichever cell you will be you will select. Next question is from Swayam Sarit. He want to ask, why don't we use hub motors in Formula cars? Uh, I'm not that much expert in hub motors, but in general, I will just answer like I have seen teams using hub motors, I guess, and there are like different teams which use hub motors as well, but there are just very basic problems with hub motors. Uh, in general, like the first problem which I will say is like about the unsprung mass, which generally like if how can I so generally what happens is like your suspensions have two kinds of mass, like there are sprung mass and unsprung mass. They are like uh, generally whatever is above the suspensions we call it like a sprung mass, which is kind of taken care by the suspensions, and whatever below suspensions is called an unsprung mass. If you are mounting your motors on the wheels, then this is part of like an unsprung mass, which you cannot control much in terms of like suspension only dampens the vibrations or like the movements to whatever which is the sprung mass, which is on the top of suspensions. It cannot do anything with the part below it. So we don't use so these motors when put on the hub, they actually add to the mass which is unsprung, and this unsprung mass basically will account for a lot of like drivability issues. Like you will start to feel that suspend you will start to like these components will move because they are not supported by suspension. So in general, this is not used like because of that major disadvantage they have. Other disadvantages like in terms of as you are mounting this directly on the wheel, your differential or how can I say like your gear reduction to be exact, you need to maintain a particular gear reduction because whatever RPM of motor that you are going to use will be directly coupled to the vehicle. So coupled to the wheel. So there is no additional gear you can use. So whatever gear system you need to design, it has to be like either motor is of the same RPM range or it has to be on the hub only. So again, you will increase more unsprung mass. Third thing, which you will see in rule book as well, there are specific sections mentioned for like if you are going for wheel bound or like hub motors, then there's like the wires because we have open wheels, like our wheels are not covered in our vehicles. So there is a lot of high voltage wiring which will go from here to there, and which is like out of your envelope, so which can easily get damaged in case of any kind of accident or anything happens. That's why you won't see most of the persons using hub motors in Formula cars, but I think teams still uses it. And the concept which I've told you about the sprung mass and unsprung mass, if your vehicle weight is too much and your unsprung mass is less, like sprung mass is too much, then these effects can be very less. Is like a one way of looking like how can you can still have a not perfect but like a good drivability with these hub motors as well. So this is one of the things which I will say like cars will still use it, but they will have like a very high weight maybe, then they can have like these effects and it will eliminated or like they won't notice these effects. Next question is from Rutvik, and he wants to ask how to start the torque vectoring for real wheel drive. For this question, I want to skip this question for now. I want to. I'm not torque vectoring expert, and I'm not very. I don't know much about this field, so I will say like I will move it to next session where I will ask somebody if in my team who can answer this question. Not the question I want to reply. Second is Soma Varun Maji. He asked how to detect state of AIR for T-cell circuit. This is a really important topic, and AIR's state detection is kind of being made mandatory and like stressed a lot in rulebook as well and in ESF reviews or like at any event. The reason for this is like welding of contactors of AIRs is like if you see any component in general, they are like every component have some failures, and the most important failures you see for AIRs is like welding of contactors. So because it opens and closes at very high speed and there is a current flowing, so there is a potential of welding. So this is important to detect AIR contacts. Now the methods of detecting this can be different. Like first method, which is really easy to use, auxiliary contact relays. In terms of auxiliary contact relays, you may already seen it, what I mean by auxiliary contact relays, but just try to show you a picture of it. Auxiliary contact relay. Generally, now I'm sharing my paint screen. Okay, so
Yes, Ram, we can see it.
yeah. So generally, you have, let us say this is your main relay contacts which are there, and then adding to it, we will have auxiliary contact here. So basically, within relay, what happens is you have, this is like an input side, I will say, and this is your output side. So relay basically engages or disengages, and this is your coil. So this will basically pull this plunger up. As soon as this plunger goes up, this will come in contact with this, and this will come in contact with this. So whatever voltage you have at input will pass on to output. So generally, let's say if you have a battery here, then this is your main AIR. There will be one more relay here, but like this is a main thing, which this is your primary contacts. Now, in parallel to this, when this plunger goes up, generally there is a relays which comes with auxiliary contacts, and these contacts also um, shows a continuity here. When I say continuity, like this will also be connected, and if you apply like a low voltage here, or like if this is grounded, then you will start to see the continuity of this with respect to the ground. Or if you attach this terminal to a 5 volt or like a low voltage uh, supply, then you will see some voltage will start to appear here. And basically this will confirm that whether this relay is closed or not. So you will start to see a signal. Let's say here right now it's 0 volts. If it goes up and down, so similarly here as well, you will start to see the similar signal. So this will be what logic signal. I will say like 5 volt, and this will be like a high voltage signal. So this will represent when this switch is on, when the switch is off. Second kind of method which you can use to detect whether any relay is closed or open is using voltage sensing in general, like continuity. This is more complex. This is easy method. There can be a complex method as well, which can be used. That method is something like this. If you have a circuit here like this, now for this, you need a lot of voltage sensors. This is for sure. You need to sense the voltage here, and you need to sense voltage here. Now, to say that this is a point A, I will say
Hi, Ram. I think we lost you.
we
Can
have
you hear me?
triangular voltage
Okay,
between.
there you go. All right.
Okay. Sorry, yeah, my internet connection was unstable for a while, I think. Second point is
Not a problem. We
this.
can hear you now.
Okay, thank you, Kathy, for confirming. So now, case number one, when relay is open. So when relay will be open, A, and I will write like voltage between A and C. If it is open, then this will be equal to, we were trying to see whether this switch is open or closed. So we need to attach two voltage sensors for each of the relay, and we need to see the voltage of these 2 points before the relay and after the relay. And based on this voltage, we can estimate whether the relay is closed or open. Now, in this kind of designs, I want to say like wherever you are comparing two voltages. So I was just trying to put some numbers here. Let's say like this is 300 volts. Now, when you try to sense the voltage here, this voltage sensor may not be accurate. It may read like 298 volts or something like that. And then you will start to see that at this point, there will be like 296 volts or something. So when I say equal, this doesn't mean has to be exactly equal, because your sensors, when they will read, will not give you like an exact 300 volts. So it has to be within some tolerance. So it is really important to have this tolerance defined. Like if this comes from your voltage sensor accuracies, and generally like you can see, for if you are designing a sensor, 3-4 volts within a range is good enough to say that these are the same voltages. This is like in general, I'm saying when you're designing your stuff, you need to take care of these tolerances. You may write a logic and say, okay, if this is exactly equal, and it may not work, because the things measured by the same sensors can be like a bit of noise, and then they can read two different values, but still I will say these are different. So these are same. So this is a measurement error that you need to take account of. So this is a question which I was trying to answer for how to sense auxiliary contact relays. I think I answered this question. Or one more thing which I want to focus on here. Now, in this design, as you see, we are capturing the voltage from the battery directly. And even this point is before AIRs. So you need to make sure whatever circuit which you are using has to be inside accumulator container. So this circuit, wherever you are doing this, has to be inside accumulator container, because outside accumulator container, there cannot be anything which is unswitched HV. All the HV that goes out of this accumulator container has to be only through these AIRs. So HV plus and HV minus, or there should not be any other HV going outside. This is a main thing. So whenever teams uses this, they need to make sure of this. Second thing that they need to make sure is that they don't end up shorting the battery. Remember, this is really critical here. You are dealing with HV here, direct HV, which we are using these to sense wires coming from one from HV negative, HV positive. If you do anything to these wires, like they will burn basically, because I feel like these wires are small wires, not very much, but this is like high voltage as well you are dealing with here. So try to design this circuit with, in absence of HV, like try to have this connector open internally from the battery pack, and then you put this everything here, and then try to test the system. So don't work live when this is there. So like in general, you will have some connectors here which will separate your battery pack from the circuit, and then you can put the circuit here. Third important thing which I came back to this slide is, generally, like if you use these voltage sensors, if you are using a op amp based sensor, it generally have very high internal resistance, like of the order of mega ohms. If you are trying to sense a voltage from like a good voltage, which is good, but if you are using a voltage sensor, do check the internal the input resistance of that sensor, because you are going to connect this directly to this. It may end up like you are having a continuous power being lost here as a lost completely. So this is something like you need to see, like it should be should have a high input resistance whichever sensor you are connecting here. Okay, so this is some design things, and then I'll then move on to next thing, next question. So next question is about battery cooling systems and types of motors used in Formula Electric. It is asked by Ganesh. So Ganesh, I think I have answered the first question. Types of motors used in terms. You can see the Formula Student Germany magazine, and you can have a list of the motors which are used in Formula Electric. For battery cooling systems, I will say I have seen mainly air cooled systems only in batteries till now, and there is, I haven't seen any of team using liquid cooled system. So in general, in terms of battery cooling, I have seen only air cooled systems. I think air cooled is sufficient, if but still if you want to go for battery cooling, like liquid cool system, then you can opt for it. But the design of such system will be like a really big task for you. uh, Next question is answered. I will come to this battery part again, because there are like few questions which are related to battery more, where I will be covering a bit more about like ventilation and cooling of battery. So I will come back to this again. Design, how to ensure, like Subhanshu has asked how to ensure the proper grounding of components near the TS components. Do we need to use interlocks for the connection of signal wires, TSAL and pre-charge, or housing will work? What are the precautions should a first year EV team take doing work on HV system? So these are like three questions, I guess. First, I will come to the grounding part of active system component. Mm, this is like a common thing which I have seen what teams generally do when it comes to grounding. Uh, a minute, I'll see if I have something. I think no. Okay, so I will say, when it comes to grounding, I have seen in electric competitions that people generally go for like structural materials, like they start using wood or plastic more and more. Like they will mount a motor controller on a plastic box, or on a wood box, which is like a kind of, they try to think this is an insulator, so which is a good thing. I think this is what the perception they have, but this is wrong. This is absolutely wrong. This is like, I won't recommend these kind of things. The reason being, like these materials are more like more fire like they are more you can get these materials can catch fire easily, and even there is no use. So they are even making, how can I say, the grounding principle in electric cars useless if you are using such kind of materials. Now, when it comes to grounding, I will say, let's say you have a component. I will again use the same paint thing, and then I will try to have a component here, and this component have some tabs. These are some tabs which, and this is an inverter. Let's say this is like a motor controller. You want to ground this. First of all, whenever you start looking at a grounding circuit, do check the specification of this component, which pin have ground and how they want to ground it. So they will say how to actually ground these points to chassis or something like that. So they will be properly mentioned in the data sheet. But if it is not mentioned, generally they give a grounding point separately here or something like that. Or else you can put like a uh, simple hook, and then you can put it to the vehicle ground. Now what happens is this casing, if you see, generally it's a metallic casing. For most of the controllers, if you see, you will have a metallic casing, apart from like few BMSs which come in like plastic casings. Okay, but this is like a metallic casing, and this is like a high voltage circuit inside, and inside there will be some HV circuit. HV I will make by orange, and there will be some LV circuit as well. It will be as a green. So there's like some HV circuit inside, some LV circuit inside. HV, so I will use orange again. Now, when we start to ground these systems, so what is the possibility which can happen in the vehicle? Is like, if you have, this is your hand, let's say, you can accidentally touch these components, and you want to make sure that when you touch these components, you don't see any electric shock. So this is a simple thing which you don't want to see. Like if you touch this, you don't want to have a shock. This is a normal requirement that you want to be safe. For safety, there is a HV circuit inside, and you want to safely touch this. Now in vehicle, we have one more system which is called IMD, insulation monitoring device. Hmm. This is, let's say, this is IMD. So I'm mixing two concepts here, but I will explain you each one separately as well. So this is IMD. So first of all, your HV and LV within the box will be isolated. So all your casing of this box, uh, of the box is something like which is grounded. So this whole LV system will be grounded to this, but your HV system will still be isolated. Now, because of any problem, let's say there is some damage has happened to the component or something, this which we don't want to happen, this HV comes into contact with casing. This is not something which will happen normally, but if it happens and if you touch it and then you have some shock, to detect this we have IMD, which will basically, what IMD does, it IMD have a ground which will be connected to this ground, and it will continuously monitoring these HV cables, these HV plus I will say, and HV minus. So it will continuously be monitoring these uh, three signals, and as soon as your something happens to this, then it will detect and it will trip the HV. So wherever this HV is supplied to this component, it will open that circuit. This is primary role of IMD. Now, if you don't do the grounding, let's say you haven't done, this component is not grounded, then IMD will not be able to detect this. If it is not able to detect this, then if you touch this and if such failure happens, then you will have a shock. This is a proper thing about grounding. So this is a concept of grounding, that your system will not be safe if you don't ground the system. So this is a simple thing. Third thing that you will see sometimes, like at homes as well, generally in electric socket, you have PE as well, like protective earthing. Now this is a part of earthing or like grounding, which is here, but there's another concept of earthing. Like, let's not talk about earthing here. I think nobody have asked for it, but in charging system, this ground has to be also connected to the P part of it. This is the only additional thing which happens in grounding part. So this P should also be grounded to the chassis or like accumulator chassis. This P like a third socket, which the third big pin that comes in your uh, electric connection. So this is it, I guess, for grounding part. So grounding is important. It has to be metallic. You use metallic parts so that like these connections are okay. Generally, I see a problem happening when the grounding rules are not satisfied when we have carbon fiber chassis, because you see that carbon fiber chassis are using, then they need to be matched with copper. This is a big problem with like electric vehicles having carbon fiber components. Either they has to be completely insulated, like they should be completely non-conductive, or if they are conductive, then they has to be uh, have a good conductivity. And there are some grounding rules which are there in our rule book, and to match those grounding like the resistance requirements, you may need to add like carbon copper meshes within your uh, body. We have spent too much time on this question. Next question is, do we need to use interlocks for connection signals of TSAL and pre-charge, or how it will work? I think in terms of interlocks, I will say like interlocks can be used. This is for safety. Like wherever you are accessing the HV voltage, you need to put kind of interlocks. I will say like there can be interlocks. I will define them like in terms of two things. Not mandatory in terms of Formula Bharat. I will say like we need to have interlocks in only HV circuits wherever we have like HV connectors. But you can give additional interlocks as well wherever you feel like you want to give. Let's say this inverter, you have designed this inverter by your own. There is a potential of HV exposure if you open the casing. So what you can do is like you can give a one more interlock in the casing as well. So let's say like if you have, this is your casing, and this is the base of the casing, and you can simply give like two wires which are like attached to the I need this. Okay, so two wires which are going in and coming back, and there is a closed loop here. So whenever you close this on the top, these two wires will get the continuity from here and here through this loop. So you can even give these things on the casing as well. Like it's, let's say if you want some box, if that box is opened, and then you can put this as a part of shutdown circuit. So if this is part of shutdown circuit, then this will open AIRs. So you can provide these small interlocks in your system as well to improve the safety of your system. So you can give it here. You can have like, if let's say you have some potential, like you know your system better. If you have designed a T-cell PCB circuit, you have put it in a casing, how delicate that casing is. If you see there are high chances that the casing may get open, even if some shock comes, like a small shock, and your teammates or your driver may be in danger in that case. So you can just give a small interlock there like this, and you can use simple connectors, like just they will, when you close the casing, these connectors are locked, and then they will be part of shutdown circuit. So this is like you can do a simple interlock kind of things you can use to improve the safety of your system. Next thing is what precautions a first year team use while doing work on HV systems. I think this I won't answer too much elaboratively, because like we have a training module for specifically for this purpose, where we have like for ESOs and for ESOs to go through that training, which mostly explain everything. But in terms like basic principles, I will say like you need to use, so it mainly outlines most of the things, but in general you should never work on high voltage. Like this is a basic principle that I will say, never work on high voltage. When I say never work on high voltage means I will say live voltage. Even when I was saying here that these circuit requires a wiring to be implemented in high voltage lines. Always have some connector here, which you can disconnect this HV, and then you connect this, because you cannot work with gloves all the time. So you should never work live. This is in reality as well. Nobody works live apart from when you are working on battery pack. Battery pack is the only thing, because you are building the battery pack. If you are assembling it, then there is no option. So then you need to use the gloves, you need to use eye glasses and everything, eye protection and everything, then only you should work. But you should practically, you should never work on high voltage. So if you are working on high voltage, like if you have some system you are checking, take out the HVD and then start inspecting in vehicle wiring. If you have something in accumulator, then first you will do is you will take out the maintenance plugs. So these are the systems which will kind of eliminate the HV. So the main principle is never work on live HV. This is the most important thing. And if you are working on HV, just to take measurements, nothing more than that. Don't work, just take measurements. So like if you want to have, you have connected this circuit, now you want to just check it. And while you are taking measurements, uh, use a reliable instrument. First of all, I've seen teams use very generic multimeters, like not high quality multimeters, but I will say like use something reliable. Like I will say no, don't use a multimeter which you don't trust it. Like generally you apply something, you read zero. Next time you apply, you read 12 volts, and then you have to do something with multimeter, like you vibrate, like you do something and then you shake the multimeter and then it gives the correct reading. Like throw away these devices. If you have such kind of measuring instruments, throw away these devices, use a proper multimeter, because for HV you need to be sure whether there is HV or not. So like use a very high quality voltage measurement, at least keep one just for checking it, and don't use for anything else. So for HV, like use a specific tools. Similarly, for in other tools as well, if you are having spanners, if you are having screwdriver, keep the HV tools separate, because HV tools will have a particular insulation coatings on them, and those coatings do degrade with time, or if they come in contact with greases or like chemicals, they may not be same. They may not provide the same protection as they used to provide when they were brand new. So keep your tools perfectly clean, separate. Don't let anybody else use it. Like your brakes person should not use those tools. Your person who is assembling your suspension should not use those tools. So these are like important things. Then your area has to be properly segregated. Like you should not have welding going on in parallel to your battery cells and those things. So these are like few basic things which you need to take care. You are using gloves, but do check if the gloves are perfectly okay or not. If you are using eye eye protections, make sure like they are not loose. It's always advised to have a thread around your eye, whatever eye protection you're using. So you can put an extra thread or like extra support, so that they never fell down from your eyes. So this is another important thing. Like don't be shy to just put a thread over it. Like just it will be for the convenience as well. Don't wear anything like watches, or like how can I say, like anything on the hand, or like on the even like I was bracelets, necklaces, or like anything ornaments on your body which can easily fall into your battery pack or something like that. And the most important thing is, if somebody, let's say you are working not alone, you have somebody who is supporting you. First of all, you should never work alone on a battery pack if you have it live. um, if you are working and somebody else is there just to support you, if even if he is a first year junior or second year junior, make sure that you train them for to have like a proper shutdown procedure. Like what should you do if you see this? So just pull this button off, or press this emergency switch off, or something like that. So do train everybody who is there. These are generic, but I will say more detailed when you can see from there, from the training material for ESOs. If you don't have it, you can mail to us. We will share you the training material, and this will give you a step-by-step procedure. Next is, I think this is a rules question. Swapnil has asked, the side members behind MRH also as a accumulator protection. So I should have, I think this is SES related questions. And I'll say if you ask it to the rules mail, I think our SES team will be able to reply this question. Next is from Pratik. You want to ask, where should we start TS design process, or what are the basic requirements we need to have before we start working on design phase? I think this is something which I have already explained, but if this is with respect to HV system, then I think this I have more or less covered, because tactive system is something with respect to powertrain and everything high voltage system. Next is how to design accumulator and cooling system. This is again asked by Pratik, and then Manav has asked, he is interested to know more about battery packs. So I will say like this is I will be stopping the session here about the battery packs, and this is like a final question which I will answer. So this is like, and then I think we will have one more session to cover, like there are a lot of questions now I can see. So I will be putting them in the next session, but this is the last question today I will answer, and then we will have like a next session soon, so I can reply your next questions. Now I will go to a battery cooling and ventilation, which is like, I think there are below as well. I can see a few more questions asked by a lot of persons about battery cooling and those things. I will right now. I will erase this. So when it comes to battery cooling, I will open one more page.
Ram, sorry to interject, but it's
Yes.
also possible to respond to those other questions via email as well, right? Via the electric group, since we've got the email address.
Yeah, so I think the rules questions I can reply on those on the
Sure.
email.
Yeah.
That's
Okay.
straightforward.
Okay. Great.
So I think Shivangi has asked a few. Yeah, but I will try to see if they're already in the rules email. Then I will
Yes.
reply them first after this meeting.
Sounds good. Sounds good.
So this is like I will just say about like battery pack and what kind of battery packs generally you see. I think in Formula student, it's like my categorization. It can be anybody else can define it differently. I'll say like, as in rule book as well, you will see one is like the sealed and not sealed. When I say like a sealed battery pack, I have seen it only one battery pack till now. So I will say 99.99% of the battery packs that are there are not sealed. When I say not sealed, I want to confirm you that what is a sealing mean. If this is your accumulator and you have put a lid over it, this is your lid. Generally there is no cooling. Even right now there are no cooling vents in this accumulator. You have just put this lid over this, and you have put the lid on it, and you have put some screws. Yeah. Now when you say sealed, this is still not sealed. Like if there are chances of even air going out of it, this is not sealed. Now this point is really important with respect to ventilation, because whenever lithium ion cells, if anything happens, they kind of try to create some pressure, and the main thing that we want to avoid is accumulation of gases. The gases which are there, if they accumulate, then only they can explode or do something. If they easily go through this, then there is no problem of fire or something like that. So these accumulation of gases is not happening, so this is not sealed. So even if you are not providing any cooling or anything, you can by default you can say your system is not sealed. This is not, this is easily, so your gases can easily fart from here. Like if there is enough pressure, even the holes of your, like the screws that you have drilled, they are not particularly like fully sealed. When you see sealed battery packs, like they will be using the proper sealant. If you have done the same thing now, I will copy the same thing here. So right now, again, in this battery pack, there is no cooling or ventilation at the moment. I'm just putting a lid over a box. And if I have used special sealants here, only thing which I have added here is like I'm using sealants here now. Uh, and if I use the proper sealants and I seal it in a way that there is no air that can come out of it in any way, then it is a sealed battery pack. Generally, you do this, or you generally weld it permanently, like, and then always like you put some sealant and then you do a proper packaging, like either you weld it or like you braze it if it's aluminum. So it's completely sealed. So now when you have not sealed pack, like 99% I'm saying you will have this, because you are not going to use this lid permanently onto this. If you are using this, then during technical inspection, I guess we won't be asking you to open this. You need to present proper documentation, like to be able to see what is there inside the battery pack. So this is a complete professional work, but I think most of the teams do this, which is they don't seal it completely. So in case of sealed here, then you need to provide like pressure based switches, like switches which are pressure based. So if pressure is more than some value inside, then they will vent. So for venting, you need to provide those switches. Otherwise, in these cases, there are no switches required. Venting is easily possible. This is the main thing, which I want to say. Next thing is in terms of cooling. So this is just a ventilation part. Till now, this is just a ventilation in case of anything happens to the cells, their gases want to come out. Now, in terms of cooling design, you will start putting these battery pack into two chambers. This is the basic requirement which we have, and you will have two different compartments of this battery pack generally. This one part is where you will keep the cells, and this one part is where you will keep all your AIR or fuses or any kind of circuit which is there. So this is like two segment categorization of this. Now these cells, there will be different kind of cells. Now again, I will say, like, if you put like these cells, this has to be put into segments. Like if you just start with few segments, let's say you divide these cells into 4 segments, then you just put segments in this. These cells. Now, when we say in terms of currents, let's say they can be electrically connected, but first we will talk about their physical locations. So if I talk about their physical location with respect to cooling, considering this is a metallic box, the cells which are at the edges. So when I say edges, like the cells which are touching this, and this is metallic, and if cells are like touching this, or there is some metal separator you have given, and these are in contact of this, then they have chances of more heat dissipation or even heat absorption as well, I will say. So like if outside temperature is more than in cell temperature, then there can be a heat flow inside, or if this is more inside temperature, then heat flow can be outside. So they have something to for heat exchange, basically, I will say. The internal cells generally doesn't have like much of the contact, so then you need to provide them such kind of surfaces if you want. Generally, like you will have something here there, but in general, what I want to say is, not every cell physically have the same amount of heat transfer mechanism or heat transfer medium available. So depending on physical location of the cells, they have different heat transfer rates. When I say heat transfer rates, it means like if there is one cell at this location and one cell at this location, if I give them the same energy and same losses, then the heat loss will not be same. So temperature increases will be different in these two cells, even if I'm giving them same energy. Even like one cell here will have a bit different because it is in contact with different surfaces. And these surfaces may not be same as this surface. So it all depends. So every cell in itself has a different temperature increase if even if the same energy loss is there. This is important like to do your flow simulations, like how much temperature they can increase. So generally like in battery, these losses can be represented by I square R. I is your internal resistance. So this internal resistance, and there is some self-discharge resistance as well, and some different like resistances which are there in battery, which you can take account of. And then you can just simply calculate how much the I square R losses based on your cycle. Remember when I talked about the simulations of the battery on a particular cycle. Let's say I will draw it again here. We had some volt velocity going with time, something like this. Now when you do some simulations, you can easily achieve, like if you fix this velocity, you know your mass and everything, you can see kinetic energies and power from here. And I think you can transform this from your simulation into a current profile. Like this is your current profile and this is your I will say. Like from velocity you can transform it into current profile. So like if you are running on a curry track with this velocity, what kind of currents you will be expecting to consume, and then these currents you can take I square R internal resistance, and you can see how much heating you will think it will be produced here. And then you can see whether or not if this energy loss at this point, considering the environment that is have, like what all surfaces it is in contact with, if that energy it gets, the temperature increase corresponding to that has to be less than the specification of the battery. So it should be generally like 65 degrees, I guess, maximum. Some batteries even more, even less than this, like 60 degrees. Case number one, in general, you will say no cooling. If there is no extra cooling that you are giving, then if you are not meeting this, then you will think of some cooling. And then you will start to add some cooling factors like some airflow to your design. And this has to be done in simulation, like, or you can do even calculations as well for your battery. And these can be easily searched on like internet, I guess, how to do these simulations, and even some tool sets are already available to do these thermodynamic simulations. If, even with airflow, you think like these rate of dissipation is too much, so that temperature can still go more than 65 degrees, which is a safety limit, then you need to find of some more alternative sources. So you can think of something like water cooled. But generally, I haven't seen water cooled system to be introduced. Now here, another thing which I want to point out is, generally I've seen teams end up using, like, whenever they start the vehicle, their fans are always on. Like, don't know like why they do this. Their fans are always on. The fans has to be temperature driven. If you think logically, like you cannot have fans on always. Like if even if you start your vehicle, you will start like the fans have turned on, so they are indirectly like circulating air in these cells. But what's the use of it if you are not using these cells and you are just wasting power? So your LV battery will go down or HV battery will go down. So it's always logical to have a controller for these fans as well in terms of temperature. So you can have some temperature sensor controlled fan, which is like it, or safely you can have always on, but what I'm suggesting is you can have something like a temperature based. So you may not need it always, but whenever you need it, you can switch it on and then you can have it. In terms of airflow, I will just say one recommendation. If you are using airflow circuit, the airflow, avoid having an airflow in this direction. I will say. This direction is something like, because we keep this compartment separate, AIR, fuses, because this is a hot components, like fuses can blow, AIRs will be carrying very high current, switching and everything. These here it will be like components can heat up, so try to avoid this kind of flow, like air going from this direction and going there. You can have opposite flows, like you can have air coming from here and then going there. Now once you have this ventilation and those things, the last point before I conclude this is you need to confirm the rain test plausibility as well. So now how to comply with the heating, like for design you need to provide some cooling as well. Let's say you done some calculation, you found out that your vessels are going 65 degrees, you need air cooling. You have calculated size of fans as well, what is the airflow required, and then you have found out, okay, you need to make big holes in the accumulator now, and now you have rain test on the top and how you should comply to everything. So then I will suggest, like generally what teams do is they make a complete like body enclosure, like which is like covering these holes, and they obviously they leave some gap as well here for the airflow. And this a kind of, because generally rain test, and it has to be rain test, like there is a particular specification of rain test, like the rain will always be falling from the top first of all. And the second case, this is like a light rain, and second thing which can happen is, like if your vehicle is moving, then there can be some splashes coming from below. This is the only thing which can happen. So we need to only take care of these two scenarios while we are designing this. So anything which is like output, so like there should be an air duct which will be going, and it has to be like, or you can put some covers here, like like a mm, like this is your battery pack, and you can put some cover like this, and below this there are fans here, so that the water will not, whatever water will go from here will simply go to this path here and will not go inside. So try to make such kind of profiles here, and from below as well you can try to protect. So like make sure there is some body part in your vehicle which is obstructing this as well, like if there is any splash coming from outside, this is not going in. So like this is something which you can think of. And then there is a hole here which, if the water comes here, then it easily goes there, so it doesn't enter the battery pack. This is in general the thing. Next thing, which is again from the rules, that these holes has to be such that you should not be able to put your fingers into it. So there's like a particular, how can I say, rule which tells you this, that your finger you should not be able to put in high voltage parts. So these has to be protected by a mesh, something like, generally you will see finger protectors. You call this mesh as like finger protectors, so that you cannot put your fingers in. So there are different kind of finger protectors which comes for the fans, so use those things as well. I think this is it for today. We have extended the session already, I guess. So I think I will conclude the session for today, and then for the next questions we will have another session. I think I was able to answer your questions properly.
Yeah, and also Ram, I think as we mentioned before, that if it's possible, we can email the persons directly, because we have collected your email addresses,
Okay.
especially on questions that have not been covered. I think we can do that later on as well. And also one more note I wanted to add is, I know earlier you mentioned about the track details and using Google Maps for curries details, but if teams wanted a very close version of the track that we run at autocross and endurance at Formula Bharat, you can go to formulabharat.com/downloads or the downloads page on the website, and scroll down to guidelines. In that you will have track maps as a folder, a Google folder, and you can download these maps. They are taken they are up to scale, so you can use there are certain tools in SolidWorks or in any platform that you have that you can sort of mirror it and then get the dimensions accordingly. We've put one dimension of a one straight length, and you can accordingly measure the dimensions for the rest of the track. So if that's something that you're interested in, this information would be there. Also, Ram, before you head out, I know every time we have these Q&A sessions, and we don't really ask you a few other questions, which basically we wanted to know more about you. So before we end this session, we want to ask a few things. So currently, I know you're working and you're also studying as well. And so therefore, I mean, huge rounds of applause for you for taking the time to, be here and, divulge your knowledge to all our participants. Um, but we
Thank
wanted to
you.
know what drives you, to support Formula Bharat, to support Formula Student in general. We know you're so involved, you're actively involved at FSUK as well. And what is it that drives you and motivates you to be a part of this platform? Sorry, trick question. I know this is not a part of the technical technical
But
part you were committed to, but I think this would be great for our students to know as well. And because you're achieving so much for participants after they leave this platform, it's something, it would be great for them to hear as to your journey and how you got there, and even your involvement with Formula Student, how, why, the details.
this is like, I'm like I said, like you said, I haven't prepared anything, but I think my passion for Formula Bharat basically comes from how I spend my time in college and what my struggles were, and how I feel that education system in India is not something which uh, drives the students in a proper direction. When they start to think about any problem solving, they don't actually go in proper direction in terms of like how to approach a problem. And there are like different kind of things which like there are not resources properly available in terms of knowledge. So these things I realized later, like I was thinking a lot of things wrong in my, like when I designed my cars, formula, like I participated in Formula Student events, and I learned it by experience. And those experiences, like I wanted to contribute back to the students, like in terms how they should do it so that they don't make the same mistakes. I'm not saying like just in terms of Formula Student, but this is engineering is basically a learning attitude, like how should you see things and how should you see things with respect to common understanding. Like, so this is a main driving factor. Like I just want to have, I don't want anybody to feel like the same way I used to feel, like and that point in time, like I think when we started like in 2012, I guess, yeah, when we made our first car, we were scared of like there were no resources with us, nothing, nobody to guide us, we just doing on our own, nothing. But here, like that vacuum that I felt, I just want to complete that thing, like at least I can contribute. And another thing which like I have learned now from like last 5 6 years, I have worked in EV industry, and that knowledge kind of uh, I wanted to share. Like I don't know, in the end, like I'm just accumulating everything, and I like to share things. So this is the main thing.
That is that is itself pretty great, and the fact that you think about that and you believe that is so important to give back and to ensure that no one's in that same position that you were in. I really applaud that, and I'm sure students too appreciate that as well. And before we let you go, I'd like you to tell us a bit about what you're studying right now, and why you're so passionate, or why you were interested in that topic as well.
Uh, uh, think that my main focus, like I was in EV industry, and I worked there like from last 6 years. But I always like from the starting, like I always had a passion of physics, which is like my closest subject. And I went to engineering just by coincidence, I will say, like, because this is what generally a stream which being an like if you are good at studies, your parents will force you to engineering. This is like a generic thing which had. But like I had
That's true.
always passion about physics, irrespective. I didn't like engineering, like, but engineering is like closest to physics I can get. So I still like, for me, physics is physics. Like I still don't see like mechanical things and electrical things separately. I still study the physics, try to understand every bit of it, which kind of drove me to my current research. I'm pursuing my master's in nuclear fusion, which is like a process which happens on sun, like which kind of generates energy. And if in worldwide, like there is a big power plant like ITER is a project which is going in France, which is like millions of investment. And we are trying to build a sun on earth, which is like we want to solve the complete energy crisis, and using the very like very phenomena which is happening on the sun to create like just combine hydrogen and make a helium and then some energy. So that kind of equipments are being made. They are still not called equipment, they are still like experimental reactors. So we are still learning and try to productionize those things. But this is something like which I started working on EVs, I started to realize that EVs are not the ultimate solution for like global warming or like the kind of thing you actually aim for, because you still end up like, if the generation is still not green, then obviously like you cannot practically say that EVs are green. So I just thought like it's better to work on like a green topic. And second thing, like which aligns to my physics, like I always wanted to move to physics, which like a research part of things. So I have seen engineering now, and I am kind of, how can I say, like at my saturation in terms of learning in this field. So I'm just exploring a new field now, which I always wanted to explore, and I'm really enjoying it now.
And
So
that's really great for our student body to understand that this is not the end of your learning. You will always keep learning, and there will be always new things that you would be interested in exploring. So this is your bachelor's is not the end and be all of everything, and including if you choose to change your industry or even look into different opportunities out there in terms of what you'd like to study and pursue, you should go for it and definitely explore. And you know what's funny, Ram, is that I think around 10 years ago, the first news had probably come out on the newspaper that there were a bunch of physicists who were working on trying to, I believe it was a sort of reactor to harness energy from the sun or make something similar to the sun over here in on this planet. And to know that someone in our alumni base is currently working in that same field, it is quite like a deja vu experience for me. So,
uh,
so thank you for sharing that, and I really appreciate it. Again, thank you for doing this session. And I know it went long, but this is something that you love, and you love engaging with the students. To our attendees, thank you for joining in, and for your questions as well. Please feel free to send your queries into Formula Bharat electric@googlegroups.com. This is also on the description on the YouTube channel as well, on the YouTube on this video as well. And before we head out, please feel free to subscribe to our channel so that we can update you with upcoming live sessions and upcoming videos that we have. Ram, thank you again. And to everybody, have a very good evening.
thank you, Kathy.
Thank you.